Hi, welcome back. Algebra 2. Today's lesson is 3.3 on square root functions. So square roots are natural inverses of squaring. In other words, to find the square root of an input, we must find a number that when squared gives us that input under the square root sign. So for example, f of x equals x squared. Remember how to find its inverse, y equals x squared. Switch the x and the y, x equals y squared, and then solve for y. Therefore, the inverse of y equals x squared is y equals rad x. Um, Hopefully that makes sense. We're just going to do some examples of actually graphing these now and see what they look like. So exercise 1. Consider the two functions f of x equals radical x and g of x equals rad x plus 3 minus 2. All right, so when we graph, anytime we're graphing, right, I'm going to tell you right away, use your calculators. So when we graph this, pull your calculator up, get your table, and do your points. Graph your points. So for this particular one, it's going to be here. It's going to be 1, 1. It's going to be 1, 2, 3, 4, 2, because the square root of 4 is 2. Square root of 9 is 3. So this is what f of x looks like. Now, when we do g of x, there's two ways that you can approach this. One is put it in your calculator and just do the same thing, get your table. But when we take a look at this situation that's right here, basically we can translate this because we know that we're going to translate this. The x is going to change signs to -3, and the y is going to be the number that hangs off the back, but we're going to not change that sign. So this translates -2, -3. So I'm sorry, -3, -2, -3, -2 down here. So this one, 1, 2, 3, 1, 2. This one, 1, 2, 3, 1, 2. This one, 1, 2, 3, 1, 2. So this is what g of x looks like. Again, if you're getting confused with the translating, use your calculator. All right? Label its equation, which we did, f of x and g of x. Remember what the rule is, that if you have more than one graph on a set of axes, you have to make sure you label them. All right, so C says state the domain and range of each function. So after you get that written down, meet me down at the bottom because I have to pull this out of the window of the smartboard. So the domain of the square root of x, or rad x, is going to be, and it says to use set builder notation. Let's change the color. We'll go back to green. So domain is going to be x such that x is greater than or equal to 0, and the range is going to be the same. When we take a look at the domain and range of g of x, this is going to change because our x translated, so x has to be greater than or equal to -3, and the range is going to be greater than or equal to -2. Going back to domain and range, that should not be overly difficult for you. But as we can see, the domain of square root functions are oftentimes limited. So my apologies, there should be a space in here. Limited due to the fact that square roots of negative numbers do not exist in the real number system. So that's why if you look at your tables, you will have errors going on for your negative numbers or the numbers that make the value under the square root negative. All right, so when you're ready to, I'll meet you at exercise 2. Which of the following equations would represent the graph shown below? Now, I'm hoping you recognize that this one is opposite of the ones that we just did, which means that the negative, there's going to be a negative in front of our x. So as I can look, this one has a negative, this one has a negative, this one does not. and this one has a negative. So 3 is the only one for sure that I know is not represented here. And the rest of this, you could put this right into your calculator, or you could recognize that this is a translation. It's a translation. It just translates -4, 0, and then pay attention to what that would look like. So -4 means that next to the x, I change the sign. So this would be my answer right here, because it's the only one that follows that rule. And again, if that's confusing to you, you can put all of these into your calculator and see which one matches the graph that's given to you. Exercise 3. Which of the following values of x does not lie in the domain of the function? Now, we're going back now to another lesson that we did where we recognized that x minus 5 has to be greater than or equal to 0. All right, because the function cannot have a negative underneath that radical. So we add 5 to both sides, and we have x is greater than or equal to +5. And if you looked at this on your calculator, it would do the same thing. Your table, when you did x, y, now this means what works. So at 5, you would get 0. Anything below this, you'll get errors. And then above it, you're still going to start getting some decimals. All right, so which one, x is greater than 5, but which one does not? So 6 is greater than or equal to 5. 5 is greater than or equal to 5. 7 is greater than or equal to 5. And 2 is not. Again, if you looked on your calculator at 2, you would have an error next to it. So exercise 4 is a repeat of that lesson. It's asking what is the domain of each one of these functions that are represented here. So we're just going to do the same thing and say x plus 2 has to be greater than or equal to 0. So x has to be greater than or equal to -2. Don't flip out from the fractions. They're not that hard. All right. Here we add 2 to both sides. We get 3x is greater than or equal to 2. Divide both sides by 3, and x is greater than or equal to 2/3. And the last one is 8 minus 2x has to be greater than or equal to 0. Minus 8. Beware of your signs. Minus 2x greater than or equal to -8. When we divide by -2, reminder that the signs change as well as the numerators, so x is less than or equal to 4. We're going to be dealing with mostly linear equations underneath, or linear expressions underneath the radical, but I wanted to show you an example of what happens when you put a quadratic underneath the radical. So in exercise 5, we're going to consider this function right here, which has an x squared as a quadratic under the radical. So A says sketch the function on the given axis. Notice that this is a quadratic under the square root. All right, so when you put this into your calculator, and that's exactly how you're going to graph this one, 1, 2, 3, 4, 5, 6. So I look at this and I say, well, I can actually factor this to x plus 6, x minus 2. So I know my zeros are at -6 and +2. And if you take a look at it on your calculator, it looks something like this. Kind of cool. And then it says, what's the domain and the range? Easy enough. So our domain, it doesn't tell us how to do it, but we've been doing things in set builder notation. So why don't we continue doing that? X such that, now be careful, we're going to have two different domains here. We're going to have x is less than or equal to -6 and, or, sorry about that, or x is greater than or equal to -2. All right, and the range actually is a little bit easier because it's y such that y is simply positive. So greater than or equal to 0. Now this has to be an or in here, and that's where I almost made my mistake. This has to be an or in here because it's going to be one or the other. If I said and, it means they both would happen at the same time, and that wouldn't be able to happen. So that has to be an or in between it. And it looks like the oars of a boat, right? They kind of go in opposite directions. All right, so quick one today, only 10 minutes. So if you were given the instruction to continue on with independent practice, you can do that. If not, we'll just see you next time. Until then, make good choices always.